So in this video, we're going to go over what the law of cosines is. Okay, so taking a look at this now, we have this figure here. All right, and our your initial thinking should be, okay, it's definitely not a right triangle. I don't see a right angle marking. And if we want to try to solve for one of these angles, we should always try to see if we can use the law of sines first. Okay. But looking at the problem, explain why we cannot apply the law of sines to solve it. All right. So remember the law of sines, right? It's like sine of a over little a is equal to sine of angle B over B. All right, so let's try these two. So if we use A, for example, sine of A over 8 equals sine of B over 19, all right? We have two variables, right? A and B, they won't work. So what's happening is that there's no angle, right, given to complete the ratio using the law of sine. So even if we were to try to use C, you would have the same thing. Two of the angles would be missing, so we can't have a complete ratio. All right. So if that's the case, if we take a look at what's given here, we're given all three side lengths. All right. So it's not ASA, AAS, or ASS in terms of the given information. It's SSS. So for that problem there, we can't use the law of sines. So we're going to have to use the law of cosines instead. All right. So it says a generalized form of the law of cosines is the Pythagorean theorem. I think it should actually really be the other way around. It's like the Pythagorean theorem is a specialized form of the law of cosines. So it says using a trig function, write an expression using to represent h using capital A and little c. Okay. So if we're looking from angle A, if we're using A and we need to have H and C there, it looks like we're going to have to use the sine function. Okay, so we're going to say that H is equal to, or actually, let's do this first. Sine of A is equal to H over C. And then when we're going to solve for H, you'll have H is equal to C times sine of A. Okay. Using a trig function, write an expression to represent R using A and C. So if we're looking from angle A again, if we're using R and C, it looks like we're going to have to use cosine. Okay. So cos of A R over C, and if we're going to isolate R, it's going to be R is equal to C times cos of A. All right. And looking at the original thing here, A squared equals H squared plus B minus R squared. We're looking at it like basically from like this small right triangle here. That's why it's true. Where essentially we have a small right triangle here. A is the hypotenuse. And then we have H is one of the legs. And then B is the whole length. It's the length of AC. But if we were to, if we know that this part is R, then B minus R is really that part there that represents B minus R. So that's why this is technically true as well. So what we're going to do from here, we have our equation here with H equals C times sine of A. We have our equation here with R is equal to C times cos of A. It says substitute your expressions for H and R using this here from the beginning into the equation. Simplify the right side of the equation. Hint, you may need to use a trig identity. So let's zoom out a little bit here and see what's going to happen. Okay. So In place of h, that h there, we're subbing in c times sine of a. So c sine of a squared plus b minus r squared. So r, we're going to replace, this r we're going to replace with c times cos of a. So that's why it's plus b minus, and then r here, we're subbing in c times cos of a squared. Okay. So what's happening here? We have to square both of these terms here. So that's where the c squared and sine squared comes from. And then with this term here, we have to FOIL out b minus c cos a squared. Okay, this is really b minus c times cos a times itself. So when you multiply b times b, you'll have b squared minus bc cos of a minus another bc cos of a, right? Because when you distribute this and then the outer and inner terms, you have minus 2bc cos of a. And then the negative c cos a times negative c cos a gives us positive, and then c squared, and then cos times cos is cos squared a. Okay. Now, what we have here, we have c squared times sine squared a plus c squared times cos squared a. That there, we just regroup them. We brought those two terms together here, and we can factor out a c squared. So we group these two terms there. And then we're like, hey, we could factor out a c squared, and then we're just left with c sine squared plus cos squared. And you should recognize that, hey, that's a Pythagorean identity there. But we still have this b squared minus 2bc cos a. So that doesn't go away. Okay. And then you'll have a squared is equal to c squared times sine squared plus cos squared is going to be replaced with 1 plus b squared minus 2bc cos a. And then we can, 1 times c squared just simplifies to c squared. All we did here was just rearrange the terms. So you have a squared equals b squared plus c squared minus 2bc cos of a. And that is your law of cosines. Okay, a version of the law of cosines. So let's zoom out here. All right, so these are three different versions of the law of cosine squared. They all basically mean the same thing, though. If you analyze the different versions of the law of cosines, okay, basically what's happening here is that if you notice, you have the little side and then the angle are on opposite sides. Okay, so if you have a squared equals b squared plus c squared minus 2bc times cos of a, that's if you were solving for either angle A or side A. If you were solving for side B or angle B, you would have the b's on opposite sides of the law of cosines. And then you would fill in the other blanks with c squared plus a squared here. And then here we would have our c squared and cosine of c on opposite sides. Okay. And if we kind of zoom out a little bit again here, all right, we have basically what's happening is that the law of cosines, okay, is like the Mr. Words calls it the Pythagorean theorem for big kids, because it kind of looks like it, right? You have c squared equals a squared plus b squared, but then you have this minus 2ab cos of c on the edge there, or on the end there, okay? So that is how we can derive the law of cosines.